Hi there, in this particular video we are going to try out some examples which are based on the BSM model. Alright, so in case we'll be having a lot of input data as you know it is required by the BSM model. In case there are any arbitrage opportunities, so what exactly we can do and how we can really exploit that. Alright, so I have an example, we'll straight away start with that. So the current stock price that we have on, say for example, XYZ Limited is $50. Alright. The volatility that we are expecting in this stock is around 25%. The continuous risk-free rate is 3%. The exercise price for the call and put options is $45. The time frame that we are looking at is 6 months, that is 0.5 years. The call option value is already given to us, or the call option is trading in the market at a price of $7. Alright, likewise the put option is trading at the price of $1. Alright, so this is something that is already given to us. Before that, I would like to bring something to your notice that the BSM model that we are learning is strictly for European options. It is not applicable for American options as such. However, we will be learning a different variant of the BSM model as well, whereby we'll be able to include a dividend yield into the equation. But right now, what we need to understand is it is completely based on the European options and not the American options. So yes, and we are given ND1 and ND2. ND1 we know when and where to use, and ND2 we know where and when to use. From ND1 and ND2 we can calculate N minus D1 and N minus D2. Alright, these are few things that we can calculate. So let's do that because we know at the end of the day we'll be requiring them. So that is nothing but 1 minus 0.779, 0.221. Likewise, 1 minus 0.723. That is 0.277. Alright, so we have gotten N minus D1 and N minus D2 as well. Alright, so let's figure out the call option value. This will be the correct option value in terms of BSM model. So C naught is S naught into ND1, we know the formula. So let's try plugging in the numbers. S naught is 50. You can pause the videos and plug it yourself and see your answer. ND1 is 0.779 that we already have, minus X, that is 45, into e to the power minus RF into T. So e to the power minus RF is 0.03 into 0.5. Alright, we are taking 0.5 years into ND2, that is 0.723. So once we figure this out, so let me calculate this part first and then I'll calculate this part. So 0.03 multiplied by 0.5 with a negative sign, I'll be calculating the E. Alright, and I'll be multiplying it by 45 and then further I'll multiply it by 7.23. So this part is 32.0506. This is to be subtracted from 50 into 0.779. 38.95. So 38.95 minus 32.0506 would be nothing but 6.9. Alright, $6.9. So this is nothing but $6.90. I've rounded it off. The actual answer is 6.899, but yes, 6.9 is the answer. But in the market, the option is trading for a price of $7. Alright, and we know that the fair price is 6.9. So in the market, it is 7, and we know that the fair price is 6.9. So essentially, in the market, the call option is overvalued. And since the call option is overvalued, what we are going to do as arbitrage opportunist is to short or to write calls. We'll be writing calls or we'll be going short calls. Alright. And once we write calls, the arbitrage opportunity or the arbitrage profit per call option that we can expect is somewhere about $0.10. Alright, is $0.10. That is 7 should be the correct price. 7 is the current price that is trading in the market, and 6.9 is the correct price. So the difference of these two is nothing but your arbitrage opportunity or the arbitrage value that you can generate out of this arrangement. Likewise, you can also calculate the value of the put option, alright, and see whether it is in line with what is there in the market. So the value of put option is nothing but X into e to the power minus RF into T into N into minus D2 minus S naught into N into minus D1. Alright, so N minus D1 we have already gotten, that is 0.221. Alright, N minus G2 is also something that we have calculated, that is 0.277. Right, so quite simple and quite easy. We need to put things in the formula. So 45 into e to the power minus 0.03 into 0.5 multiplied by N minus D2. So that would be 0.277 minus 50 into 0.221. Alright, so this is exactly what we need to do. Again, I'll be doing this bit first and then this bit. Alright, so let's do that. 0.03 into 0.5 with a negative sign. Second, E into 45 into 0.277. So we have 12.2794 here. I'll subtract 50 into 0.221, that is 11.05 from this, and the final value that we'll receive is 1.2294. Alright, so the current price is $1, but it should be 1.2294. So we can see that the put option is underpriced, as currently it is available at a cheaper price in the market at $1, and the right price or the fair price according to us or according to our calculation is 1.2294. So again, here we can make an arbitrage profit of somewhere about $0.2294. Alright, this is the arbitrage profit that we can make. And here, instead of writing puts, as we did in the previous case, we were writing calls, but here in this case we'll be buying put options, because we have figured out, or we have found out, an undervalued asset or an undervalued security or an undervalued derivative contract. So we'll be doing what? We'll be buying put options in order to make sure that we make money out of it. Alright, so this is an example how we can really test the BSM model, and we can see how we can really explore the arbitrage opportunities. So it was quite simple. Now what we are going to do is we'll rearrange the equation by inculcating dividend yield in it, and we'll see how things work out. Thank you.